Hello everybody. This is a tutorial of graphical solution of linear programming problem. There are two types of problem which we can solve through graphical method. One to maximize and the other to minimize the objective function. Let us take the example of a problem of maximization. The objective function here is to maximize pi is equal to 45x1 plus 80x2 subject to the first constraint function 5x1 plus 20x2 less than equal to 400 and the second constraint function 10x1 plus 15x2 less than equal to 450. Here the non-negativity restrictions are x1 and x2 both are greater than equal to 0. Our problem is to find out the value of x1 and x2 that maximizes the objective function pi. Let us start how to draw the graph. First, take a graph paper, draw OX and OY axis. On OY axis, we will measure x2 and on OX axis, we will measure x1. Use proper scale for measurement. From the first constraint function, replacing less than sign to equal sign, we have 5x1 plus 20x2 is equal to 400. If we put x1 equal to 0, then we get x2 equal to 20. Therefore, we get the first ordinate A, which points are x1 equal to 0 and x2 equal to 20. Similarly, if we put x2 equal to 0, then we get x1 equal to 80. Therefore, we get the second ordinate B, which is situated at the point x1 equal to 80 and x2 equal to 0. Now, connecting A and B by scale, we get the straight line AB. This is the first constraint line. From the second constraint function, replacing less than sign to equal sign, we have 10x1 plus 15x2 is equal to 450. If we put x1 equal to 0, then we get x2 equal to 30. Therefore, we get the first ordinate C, whose points are x1 equal to 0 and x2 equal to 30. Similarly, if we put x2 equal to 0 and we get x1 equal to 45, therefore we get the second ordinate D, the points are x1 equal to 45 and x2 equal to 0. Now connecting C and D by scale, we get a straight line CD. Both AB and CD line cuts each other at point G. The common area covered by both AB and CD below them towards the origin is OAGD. This area is known as feasible region. In this area, all constraint functions are satisfied at any value of the variables. Now, to find out the optimum solution, that is the combination of x1 and x2, which will maximize the objective function, is obtained by the tangent between the objective line and any point of the feasible region. Taking total differentiation of the objective function, we have dx1 by dx2 is equal to minus 80 by 45. We put 80 on OX axis and 45 on OY axis and connect both the points. We get the objective line. Here the objective line is far above from the feasible region. On such situation, we will draw parallel line to make tangent of any point of the feasible region. By doing this, we found that the objective line is tangent at point G. Now drawing a vertical line on OX axis and a horizontal line on OY axis from point G, we get the optimum combination of x1 and x2. Hence, we get x1 equal to 24 and x2 equal to 14. So, this is the way how we draw the graph and obtain the optimal solution of the linear programming problem.